Welcome once again to Learn Math with me, Brian Sapinski. So, if you're a sports fan, then you saw that we witnessed history just a few weeks ago. The Washington Nationals defeated the Houston Astros to win the 2019 World Series, and they did it in a way that's never been done before. The World Series is contested in a best of seven format, where the first team to win the majority 4 games wins the championship. This year, the series not only went the full 7 games, but the visiting team won all 7 times. Talk about gracious hosts. Until now, this has never happened in the history of the 3 major American sports, baseball, basketball, or hockey, that decide their championship by a best of 7 series. It's a pretty amazing feat, and the chances of it happening are really small. How small, you ask? Well, that's a probability question, and anyone that knows me knows that I'm a sucker for probability and statistics questions all day. So, it's time to swing for the fences and step into the challenge chamber. So let's set the parameters of this problem. We have 2 teams competing in a best of 7 series. They will take their appropriate turns, being the visiting team and the home team. However, for this problem, we are going to ignore any home team advantage variable in the calculations because there is no truly agreed upon percentage that being the home team actually gives someone. So if you want, assume that the 2 teams are playing on the same neutral field for every game, just taking their turns in appropriate fashion with who is declared the visitor and the home. Now for this problem, we're going to calculate a few things. First, we want to calculate exactly how many ways the series can play out. We know that the fastest a series can end is a 4-game sweep, and there's exactly one way that each team can accomplish that. This will be the equivalent of the combination calculation 3C0. Now, if you're wondering why I placed a 3 at the beginning when there's 4 games played, consider the next piece of the problem. For a series to finish in exactly 5 games, one of the teams must win one of the first 4 games. In a 6-game series, one team must win 2 of the first 5. And to go the full 7 games, one team has to win 3 of the first 6. The key to each combination calculation that you do is based on how many games the losing team wins before we reach the game where the winner clinches the championship. Now we calculate each combination. Each consists of a fraction where the numerator and the denominator start with the numbers involved in the combination. You multiply these by a sequence of consecutively decreasing numbers for as long as it takes until the denominator reaches 1. For 4C1, that's simply 4 divided by 1, or 4 ways to do it. 5C2 would mean you would see a 5 times 4 on top and a 2 times 1 on the bottom, which simplifies to 10. And 6C3 would show 6 by 5 by 4 on top and 3 by 2 by 1 on the bottom, which would multiply and divide together to end up with 20. Altogether, this adds up to a total of 70 possible ways that the best of 7 series can produce a winner, 35 in favor of each team. But what are the probabilities of each of those 70 scenarios taking place? That's where you have to know the probability of each team being able to win any individual game. Now, I will demonstrate the hardest example here, where each team is perfectly equal, having a 50% or 0.5 chance of winning. Now, you'll see in a minute that that's going to make the calculations a little bit tricky to follow, since they're the same for both teams. But to help you for your challenge, I will color code Team A's probability of winning in blue and Team B's probability in gold. Hey, my town colors. Next, to get the probability of the series finishing in X number of games, you have to multiply as many probabilities as necessary for each team based on how many times they win in a situation. For a 4-game sweep, it's simply 4 of the winning team's probability, in this case giving us 0.0625 or 6.25% each time. For 5-game wins, we have to first toss in one of the losing team's probability into the calculation. That gives us 0.03125. But we then have to multiply that by the 4 combinations we determined it can happen in, giving us 12.5% when it's done. The same happens with 6 games, another loser thrown in times 10 combinations. And for 7 games, include one more loser times the 20 ways a 7 game series can play out. All of these scenarios add up to the full 100% of events when it's all said and done. But here are the numbers that matter to us for the purpose of our story. If we were to say that Team B was the Washington Nationals, they would have these overall chances of winning the series in each respective number of games. And for the one exact scenario where the visiting team wins all 7 games, they would have approximately a 0.78% chance of making that happen. But now we know that in reality, the Nationals did not strictly have a 50-50 chance of winning the series. In fact, this year, they won 93 games in the regular season, while the Astros won 107, which means that they were the underdogs in this series. Using this information, here is your challenge in today's chamber. First, use the number of wins each team had to calculate their probability percentages of winning any one game. Then, put those numbers through the model that I've demonstrated here to calculate all the key probabilities that I stressed, including the most important one of all, the chances of our historic all-visitor victory playing out. When you think you found all of your numbers, email them to me at brian.sapinski@gmail.com. And if you're right, you win the chance to select any elementary or high school math topic that you would like me to address in a future video. So get to work, and to borrow from the Hunger Games for this problem, may the odds forever be in your favor. Good luck, and I hope to hear from you soon. Take care.